Cool, we're at 2 minutes past the hour, so I think we can get started. Welcome, everybody. This is a joint session between Redis and Red Hat, talking about how you can use Redis and Quarkus together. Before we start on the technical stuff, though, I want to deal with the serious life questions, which is, what is this? Any ideas, Clément?
Well, it's tomatoes with a cape.
It's super tomato.
Almost.
Almost. You'll get there next time. Okay. So what about this? What's this one?
A super pickle.
Oh, so close. So close. You would think it is a super cucumber, but it is not a super cucumber.
So what is it then?
It's a cucumber that wants to be a super tomato.
Yeah, almost. Close.
Almost. And then this brings us to databases and to data. So what's this?
A super database? Oh, a database that want to be a super tomato.
Yeah, it all gets a bit confusing at this point. So yeah, so this is either a super database or a database that wants to be a super tomato. And then when we think about Redis, then, Redis, it's a lot more than just a cache these days. So Redis really is a super database. It has the characteristics of a cache, but it also has a lot of really good qualities of a database. So let me tell you how I know this. I'm Holly Cummins. I work for Red Hat. I work in the Quarkus team. I'm a senior principal engineer in the Quarkus team, but I had a previous role as a consultant and a full stack web developer. And on every single client project I did, pretty much, we used Redis, because if we didn't, in the cloud native application, we would lose our state. And so I thought I knew Redis really well, which was stuff goes into the cache, stuff comes out of the cache, stuff comes into the cache, stuff goes out of the cache. I thought that was all there was. Turns out I was wrong.
Yeah, and actually I came to Redis from the Quarkus angle. Well, I was like, Holly, Redis is a cache. I heard that our integration was not great, so maybe we can just improve it. And I was like, well, if it's just a cache, it's just a matter of 1 week to fix it. 6 months later, I was still on the project, because actually it's a lot more than just get and set. It's I have the exact number on the slide later, but it's almost 400 commands, which can deal with plenty of things. And I was super surprised, and I found it really, really powerful while I was developing the integration with Quarkus. And then today we have Luigi.
And hello, everyone. I'm Luigi Fugaro, solution architect here at Redis. And so today I'm gonna to describe what Redis is beyond cache. So as always said, we can do a lot more things.
But what I really want to know is, I heard a story the other day from someone who got their first job, and they got their job as a consultant, and they sort of rocked up in London to start their consultancy job, and their employer told them, right, and now you're off to Bristol. And he sort of said, what? I didn't realize this. Now, he perhaps should have done a bit more homework about what being a consultant meant. But when you joined Redis, did you know that it was more than a cache?
Well, to be honest, I knew that Redis was a cache, and you can do pub/sub, so message notification. That's it. And but then when I joined Redis, I found so many different things that you can use for Redis in different use cases, and also streams and JSON, search, time series. There is a lot that you can do with Redis, with a single instance, with the cluster. So really, it was mind blowing, really, and it's not enough. I mean, it's just using Redis as a cache would not enough. You get curious about all the different characteristics and use case that you can implement.
I'm glad it's not just Clement and me who were surprised.
Yeah. So if we, I think there is like an animation, but if we can go through the entire animation, it would be better. So, okay, that's it. So Redis open source is the core of Redis Enterprise. So Redis open source itself provides a bunch of what we call the core data structures that you can see here at the bottom. Those little squares like string, bit fields, bitmatch, hashes, list, sorted set, and so on, which are the core part of Redis. And then we introduce also other data structure that you can use, such as the JSON formats. So you can access and manage your JSON documents, probabilistic. So it's more about counters, and which seems to be like a simple use case, but can be very complex to count things really quickly and in an efficient manner. And then also with Redis Enterprise, we improve the what we call developer experience, DX. And we provide a bunch of tools and libraries that you can work on, like, for example, with Java, so with Quarkus and .NET, JavaScript, Node.js, but not only those programming languages, we also support Rust, Go, and I mean, probably more than 60 programming languages. And again, going up, and we also provide different engines which are built in with Redis Enterprise, which is we call it data processing engines. For example, we have the engine for event streaming and data integration, which is also known as a change data capture here in Redis. And we have the query and search engine that you can use to create primary and secondary index for your data to query and search and aggregate your data in a full text search manner. And then also we provide server-side engine to actually inject your own custom logic with your own code that can listen to Redis events, trigger your code, and do your custom logic. And then, and it's the top part, which are the architecture characteristics. With Redis Enterprise, we provide linear scalability, high availability, durability, and backup restore, because it's true that everything is managed in memory, but it's also true that you can enable persistency. And so everything gets written to disk in different ways with what we call AOF, which is up and only file. It's like I would say a transaction log of all the write operations, or RDB, which are snapshot that you take at a specific interval. So to provide backup and restore functionality. And then with Redis Enterprise, we provide also distributed deployments. So it could be different data center, hybrid cloud, so on-premise, on cloud, multi-cloud, multi-region, and so on. And then comes also with the tier memory access, because as I said, everything is managed in memory. And when it comes to gigabytes of data, then hundreds, the RAM is still a cost-effective solution. But when it comes to another order of magnitude, like terabytes or petabytes, the infrastructure for the RAM would be very costly. So what we do is extend the concept of the RAM by providing access to flash memory, mainly SSD disks and VME. And so you can split your data between the RAM and the disk. And so you can manage more than just gigabyte, but also terabytes and petabytes of data. And then with one single Redis enterprise cluster, you can have multi-tenancy, which means different databases that you can use for cache or stream or time series, whatever. And all those databases are segregated, so isolated from each other. So every application will access its own database without interleaving the other databases. And then, of course, with multi-tenancy comes security. So, and then we provide RBAC solutions, ACLs, certificates to access and authorize your client application directly to Redis. That's the overview of Redis. What you can do actually with Redis, and we receive a lot of questions and demands regarding two main topics in Redis, which are our query engine, search and aggregation engine, which is Redis Search, and of course Redis JSON, because query search can also be used with Redis JSON. I mean, I think that the JSON format doesn't need any kind of introduction. It's just a format. I mean, everyone maybe probably they don't even know, but they're already using JSON somehow. And the cool thing is just it's an exact text format where you can actually specify the characteristics of your documents. Here we have an example in the first red section, how you can insert a document JSON within Redis. The command is JSON set, then you specify the key, and then the JSON document. And you may have noticed this dollar symbol at the beginning of the JSON, which is actually the root element of the JSON documents, because and to provide access to the JSON documents, not the entire JSON document, maybe just a piece of it, or a nested object within the JSON documents, we implement the JSON spot specification, which is a query language to access the JSON documents. So, and as you see here at the bottom, how you can retrieve the JSON documents, it would be mainly a JSON get command plus the key, and then the dollar symbol to specify the root element. Plus, you can also set the attribute. Like, for example, I would just want to retrieve not the entire JSON documents, but just the first name of my document, or an element of a vector, or maybe all the attributes which are rolled within the JSON document. So it gives you more flexibility, and also you need to really dump the entire JSON documents, which might be few kilobytes, but we found also often by the customer that can be also few megabytes of a JSON documents. So just to not overload too much the network and the bandwidth, you can just rely on the Redis JSON attributes. And the Redis JSON documents can be indexed, so you can have access and you can do query and search with the Redis Search, which is our engine. It was an addition to the Redis ecosystem, and so we provide access. You can index all an entire document, JSON document, could be maybe just a piece of it, and we can provide different type of indexes, like here we have in the red section. Here is an example of the Redis command to create an index. And when you specify that the name is going to be indexed as a text, the description also as a text, and then the coordinates will be indexed as a geospatial references. And below, in the blue, you have also the counterparts with the Redis Quarkus integration. And it's it's very similar to what you will implement with the Redis command. You create the index, you give a name, it's going to be applied on the JSON document. And here is the prefix, for example, of the key, and those are the attributes that you want to index. But we also have text, geo, numeral, and vector, and also vector embeddings. So there is a lot of things that you can search, query, and aggregate with Redis. And that's the introduction of Redis, the search, and the JSON part.
Cool, thanks, Luigi. So I think that already, like even just that, which is just a fraction of the capability, already shows how much there is. Clément and you and I were talking beforehand when we were preparing, and we were talking about JSON path, and Clément was saying that JSON path isn't as widely known, sort of independent of Redis. If you take one thing away, JSON path is really useful, and it's not necessarily very widely known as a way for navigating JSON documents. But then when you have the sort of the deep JSON support of Redis, and then the search support as well, already you're getting so much capability. But fundamentally, at its sort of, the starting point for Redis really was as a cache, as a key value store. And so, the pattern that probably most of us start using with Redis is that we have our application. It wants to store stuff. It wants to store stuff perhaps to a distributed system rather than just to have a single monolithic, single point of failure store. And so what you can do is you take your data and you put it into the store with the key, and then you can retrieve it. And that really then unlocks the caching use case, which is I think a simpler version of some of what you showed with the JSON beforehand, which is that you can put things into the cache and then you can get them out of the cache. And you can also set things like timeouts. But as we keep saying, that is just the beginning. And you can go past that to the 389 commands, which is awesome until you're Clément trying to make it work with Quarkus. Although I think probably even for any of us, like even if we're not actually trying to implement support for this, 389 is a lot of commands to hold in your head. So they can be simplified into these sort of groups of 20. So some of them are things that you're going to be using all the time, like JSON. And then some of them are going to be a bit more niche, like top K and cuckoo, and some of these sort of quite data geek specific ones. But even that 20 is kind of a lot to hold in your head, so we can simplify it even further. So now there's a distinction between Redis core and Redis stack. And so Redis stack is a set of modules that are built on top of Redis core that have some of that more exotic function, or that have some of that more extended function, like JSON, like search, like these things that you might not necessarily expect to find in the cache. And then the things like some of those data ones as well, like the top K and the cuckoo and the bloom. But that's a lot of words, and that's a lot of commands. And I think probably the best way to actually see some of the capabilities of Redis is to see it. So we have a demo and we have some code. So the demo is, this is a joke, which is awesome in French, and I think loses something slightly in translation. But the French word for hide and seek is cache, and Redis is a cache. Do you see the awesome joke? Yes. No. Okay, it's even worse than the super tomato joke. But so what we have is we have your standard 2023 microservices architecture. So we have a bunch of services which are using Redis as a communication mechanism and as a game control mechanism. And of course, because we work for Quarkus and we've been working on the Quarkus integration with Redis, each microservice is implemented in Quarkus. So we've talked a lot about Redis. We haven't talked much about Quarkus, so I just want to give a little bit of a mention to the Quarkus part of the demo. So Quarkus is a stack for writing Java apps. It's really designed to be cloud native Java. So you can run the same Java that you've always been using, but it is just better and faster and more suited for the cloud, because the way in which it's built and the way in which it runs is really designed for the cloud. And it's a particularly good fit for microservices architectures, and particularly for serverless architectures, because Quarkus applications start ridiculously fast. But there's a whole bunch of good things about Quarkus beyond just that start time. So Quarkus is, because it's designed for the cloud, and in the cloud, the memory and footprint is money. So Quarkus is designed to really have a high deployment density. So if you're using something like Kubernetes, you can get a whole bunch more Quarkus pods in than you could some other Java frameworks. And what that means is that like I said, it translates directly to cost. So we did some experiments, and we had an application running, a long running application serving a lot of traffic. And we found that with Quarkus, we were able to run it on a nano instance, whereas with other frameworks, we had to run it on a medium instance. So there was a literal, a direct correlation between that efficiency of Quarkus and lowered costs. And Quarkus also has a higher throughput. So it's not just about the memory footprint. It's not just about the start time. It's also more efficient in terms of its actual execution. So that would be kind of awesome all on its own. But of course, we're developers. And so one of the other really nice things about Quarkus is it's got this frictionless developer experience. So you can have continuous testing. You can have live reload, so that as you're typing, the code is refreshed without you having to do a rebuild or a redeploy. And as well, because of how Quarkus is built, a whole bunch of boilerplate that you would normally need in an application, you can just get rid of. So the developer experience is overall very, very nice, as well as being faster. So what we're going to show in, oh, no, I've gone too far. I gave away the answer to the demo. So I think we can switch now to Clement and the code, and we can do our invocation to the demo gods.
Yes, so let me share my screen. Yeah, should be fine.
I did the thing that you are never supposed to do for a demo, which is make changes late last night. Hey, Clement, I've improved this. It's better, honest.
Yep. And I spent my morning trying to make it work, but everything will be fine. So as we said, we want to build a hide and seek system. So we want to build microservices to model that game. But the first thing we need in all games is a concept of players. So a players is just going to be a structure. Here I'm using Java 17 records, but you can use POJOs or whatever. A player has an ID, a name, and a speed, because speed is very important in a hide and seek. You will see why later. Then, I will just use my build repository. So while it's running on Quarkus, I'm going to use the Spring development model with Spring annotation and things like that, because most of Java developers know it, and you can actually use that model on top of Quarkus. We have the compatibility with most of the Spring stuff. So here I have my player repository. As we said, Redis is a key value store at the core. So this will be my key, and I'm going to store my players using an hash. An hash can be seen as an hash map. So we will have a Redis key, which will be associated with an hash map, which inside will have the Redis as a player ID and the player structures that we have seen. So with Quarkus and the Redis integration, you just use a Redis data source. You retrieve the hash command, so that's the group that Holly introduced, where you have all the commands to manipulate your hash, and you can implement a CRUD mechanism like that. So this will return all the players, so using hvals, so all the values of my hash map, that to get a single one. So I want the player that is inside that, the hash stored as that key, but the value that is stored inside that hash to that ID. We can delete, we can create, and things like that. We can also do an update, which is slightly more different because we need some kind of transaction to first verify that the player is there and then act upon it. So for this, there is some kind of transaction in Redis. It's not really like the traditional transaction of regular databases or relational databases. So we need what we call a check and set pattern. So I have that first part of the code that will be run before the transaction, and then that part which will be the transaction. However, the two parts will be guarded by a key, and if that key is modified, then the transaction is rolled back. So basically, if anything concurrently modify my players, that transaction is going to be rolled back and I will have to retry. So before, what I do is just retrieving the player to check if it's there. If it's not there, well, I don't have to do anything. And if it's there, I just manipulate and set my players. So let's get this running, and it's going to be, oops, where is my mouse? Here. So I'm going to start Quarkus in dev mode. And that's my first microservice. So it's a player service. So immediately Quarkus see, hey, you want to use Redis, but you didn't configure while your Redis is running. So your profiling it just wants to use Redis and you're in dev mode. So I'm going to start a Redis stack for you automatically. So here I didn't have any Redis running, and it's actually started one here using a container. So if I go there, you will see that we have Redis stack container running for you, and all my other microservices will use that Redis containers. So my application is already running. So let's switch to the second one, which is my place repository, my place microservices, because in an hide and seek games, you need places to hide. So in that case, it's slightly more interesting. It's not a CRUD. It's a bit more fancy. So we have a set of places. We have 18 places where we can hide, and these places will be European cities. They are written as JSON document because Reggie mentioned that we can use JSON with Redis. So you have a key, you have a name, you have a description, which is, except for this one, generated using ChatGPT. The Ascens one is generated by Holly's GPT, or whatever is the name of the machine learning model you want to have, Holly. And we have the coordinates. So I'm going to take that, write it inside Redis. That's automatic because it's an imported Redis. And then I'm going to do a few things with this. So if we go to our place repository, I'm going to iterate over that set of JSON documents and insert them into a geolocal, geospatial structures where I would have all my cities inside one list. And so I can compute the distance between my different places and things like that. We will see why, because that's going to be key when we are going to play the game. Then I have another method which would just retrieve the list of places. So I'm iterating over the list of keys. And then for each one, I just want I know that it's a JSON document, but I want to represent it as a place. And I can just do it like this. So as you can see, the Quarkus integration of Redis is completely type safe. So we have all the things to do this. We have an index on top of our places. Luigi shows the code to do that. It's in another classes. But because I have that index, I can search for places using the description, like, well, what's the best cities to have a nightlife, for example, or architecture, or whatever. And it will find the right place. We will see that when I have the whole system running. So let's start that one. Okay, so let's switch now to the next one, which is our leaderboard, because a game without scores, yeah, that's not really a game. We need to know who is winning and so on. So in that case, it's a little bit more classic for Redis. We are going to use a sorted set. That's great for leaderboard and things like that to show what are the top players, who are the higher score. So basically what it does, it's relatively simple. It's going to listen on a specific topic because Redis can also do pub/sub. And when the game is over, it will emit or broadcast an event, and the leaderboard service is going to receive it. So it's going to be received as a game event, again, that's type safe. That's where everything is going to be sent and broadcasted. And if it's a game over, I'm going to update my score. So I'm getting my game event, and I'm going to increment the score of the seeker based on the number of players he discovered. So if he discovered all, he has all the points and so on. Obviously, I can also retrieve my leaderboard by just saying, okay, give me the sorted set that is stored at that key, and I want a complete set. And because we want to have the player with the highest score first, I need to say, hey, give me it in the reverse order, and so on. So that's more or less the leaderboard. So let me start it. Right, so it's starting it. So then we will have the game logic because, well, we need to play games, and that's an important part. So one thing is that these demos is actually using Java 20, and one of the features of Java 20, which is virtual threads. It's an ability to have cheap threads and a lot of threads inside your Java applications. And Quarkus already supports that. So basically, my game is runnable, which will be started as a virtual thread here. So it's actually pretty cheap to have those virtual threads. So when we start a game, well, we select the seekers, we create the hiders, which are the one hiding, and then we run it. And it's going to send a few events saying, hey, okay, first it's going to connect to the seekers, which will be another microservice. And that communication between the game and the seekers is going to use two queues to communicate. So we keep the orders and so on. So first, the game is going to say, hey, seekers, I'm going to start a game and you are the seeker. Okay, fine. And the seeker will retrieve that and start planning its moves. The second thing is the next line is it's also going to say to the front end and to all the other components that the new game is getting started. So then, because we have a virtual thread and things like that, I can just do something very simple. The seekers, every time it does a move, is going to write in another queue, and I'm just going to read that queue and until well, all the players have been reached, or if we run out of time. So basically, we just do that. I'm reading from the list, and while I have events, I'm just going to process them and so on. So as you can see here, with Redis, you can actually build an actor system very easily using just your Redis lists and queue lists, one for, well, each actors will have its inbox list more or less, and you can write like this, and it's very simple because you implement your system as a state automata based on the event you get, and that's really nice to have such kind of features. So let's start this. All right, so we have 4 of our microservices that are running all locally. Now we need the seeker service. So the seeker will be, well, the opposite of the game service. So it will read on a list too, and that's the same patterns. I'm just doing a while true and, well, get my events that are sent by the game. If a game is started, then I plan my next move. If the game is ended because, well, of a timeout, well, something like that, or because moving from one place to another one can take time. So I'm actually injecting myself events when I arrive to the right place, to the place I wanted to visit. Okay, so that would be the seeker. And the next one is just a front end. I'm not going to show you the code because it's mostly JavaScript code integrating into a Quarkus application using something that we call Quinoa, which bridge the two worlds very nicely. So I have all my system running. So let's see if we get anything. Oops. All right. So first thing we will do is try to find some places. So as I said, and Luigi, I know that you like nightlife. So let's find the best places for your nightclubbing alive. So find a place. Oh, it's going to be Berlin and Madrid. Two nice place. Well, what can we say? Well, we can also sort by name because, well, Holly is living close to London. So let's see. Yes, we can find that. Let's say if I can find places by if the description has architectures. Yes, well, we have Brussels, Bern, Copenhagen, and so on. So, but let's have all the places that we have in our system. So from Athens and Manchester and things like that. So now I'm going to start a game. Starting the game is going to go to the game, start a new game, say who is the seekers, plan the move, and so on. So let's see what we have. The game is started. Arden Slot is our seekers, and he's going from one place to another one. And it's taking time because yes, and well, it's just only two places in a few minutes, or in a few seconds. While we also have players here hiding in Luxembourg and Bern. He didn't have time, so let's do another game. Oh, it's the same. Yeah, let's go to Milan, Frankfurt, London. Oh, he found Westerbold in Frankfurt already. Oh, and he lost again. But as you can see, he got some score, so that's better. Copenhagen. Oh, that's another one. Frogman is much faster than the first hider, so he has more chance to win. Did he? No, he didn't win, but he found two players, so got 2 points. So that's great. But what's the next level? The next level is to deploy this to your production environment, such as Kubernetes or OpenShift. So it's actually what I already did.
It's very important to have production level hide and seek, clearly.
Yes, definitely. That's what I have here. I already deployed it here on OpenShift. So that's the OpenShift sandbox. So that's my front-end game. That is going my player service, place, a leaderboard, and so on and so on. So my application is running there. Okay, let's add all the places. Yes, and let's see if it's working. So what's happening here is that I didn't deploy Redis directly on OpenShift. I'm using Redis Cloud, which is a service that is provided by Redis. And it's completely compatible with what we are doing in the Quarkus integration. So you just add the Kubernetes secret saying, where is your Redis Cloud? And boom, you can just do like that and get your system running. So Super Concumber lost. Oh, that's bad. So let's help Super Concumber a little bit, our hiders. So I've implemented a second seeker service, which is named Super Seeker, which instead of picking a random place every time, is actually using the graph part from Redis to actually compute the closest place, the non-visited closest place. So when that seekers is created, it's going to take all the places, all the locations from my geolocal indices that I have, and create a graph of all those places, and then we'll travel from one place to another one using that query here. So it's using the Cypher syntax. If you are not familiar with it, it's the same syntax that is used by Neo4j and things like that. And it can be a little bit weird to write at the beginning, but it's super powerful. So I recommend you to have a look at that. And basically then what I'm going to do is go to place. What is a pick next? Well, here is that I'm just going to run my query to find the next place I need to go, which is a closer place that are not yet visited. So I'm going to go here, Super Seeker, and I'm going to deploy it to Kubernetes directly. So all my system I was running locally was using Maven. Here I'm going to use a Quarkus command line because we come also with a Quarkus command line, which will actually delegate to Maven. And I'm doing two things. I'm going to show you this here. So you have it here. While it's doing, the first part is actually building a container image and deploying it to your registry. In my case, I'm just using Docker Hub, but you can configure your registry. So a container creation is managed by Quarkus because we know exactly what needs to be done for your application to run correctly inside a container. So the second part is just say, hey, deploy to Kubernetes. And it's going to generate all the Kubernetes descriptor for you and deploy them. So if I go back to my OpenShift here, we have no, oh, it's already updated. If you log, I just want to see, yes, it's the super seeker that is running now. So if I go back here, and now I start a game, it's going to use the graph algorithm so to find the closest place every time and maximize its chance of winning. And now Westerbold has won with 4 discovery. So let's start another game. Oh, with the same. Okay, so let's see. And well, yes, he found everyone. He had time to find all the players and to visit all the cities, because every time you go to the closer one, and it's at that game, to win, you just need to visit a maximum amount of cities in a minimum amount of time. So that's more or less what I had to show you. And now Luigi is going to explain how you can run your Redis directly inside your OpenShift or inside your Kubernetes, which I didn't because I'm using Redis Cloud, but there is a way to have your Redis here. So Luigi, stage is yours.
All right, so let me share my screen.
And Luigi, you have a question that I'm unable to answer because it's really specific to Redis. So in the Q&A, so maybe you can answer after that.
Yes, definitely. So here we are in OpenShift console. Redis can be installed using the operator, and there are a bunch of operators that you can use within OpenShift. There is one specific for Redis Enterprise, and it's going to be, you just look for Redis Enterprise, and then you have the Redis Enterprise operator, which is certified by Red Hat, so it's compliant to all the specifications, and it's also available through the Operator Hub site. And just click on it and just install it. In this case, I already installed it for you, so it's going to be ready to provide all the instances that we need. You go to install operators. Here is my Redis Enterprise operator, and when you click on it, you have a bunch of description that you can, of course, read, but you also have all the manifest files that you can look at it, and eventually the events that were running during the installation. And also there are 2 custom resources, Redis Enterprise Cluster and Redis Enterprise Database. And this is because the Redis Enterprise operator is an implementation of the operator pattern, and the operator pattern, it's also implemented for the main reason to actually implement the operator pattern is one, when you need to answer, hey, I want Kubernetes to do this, this, and this for my application that needs to be deployed, it means you need an operator, because Kubernetes itself doesn't have the knowledge to all the mechanisms and all the components that needs to be installed within your deployment with your application. So if you need to specify custom resources, a bunch of services that needs to interact with each other, maybe there is an order to deploy those services, then you definitely need an operator, and that you can implement using the SDK of your choice. In addition to that, OpenShift also provides OLM. It's the Operator Lifecycle Manager, where you can manage the entire lifecycle of your operator, install it, updates, and then also provide admission controllers to prevent maybe erroneous deployment of your components, of your services, of your application. And so it provides a full overview of your operators and, of course, of your components. As such, the Redis Enterprise operator is needed because we do have 2 custom resources, the Redis Enterprise cluster, which is our architecture of Redis Enterprise, and then the Redis Enterprise database, which can be your your cache, your pub/sub implementation, your stream, your time series, whatever use case you need to implement. And I already deployed the Redis Enterprise cluster that we can see here. Just let's click on it. This is usually something that you do on the day one operation. So deploy the operator and deploy the Redis Enterprise cluster. And here we can see the details of the Redis Enterprise cluster. Then we have, of course, also the YAML. So all the characteristics of the cluster, in this case, is going to be distributed across 3 nodes of the OpenShift clusters. There are the resources, how much CPU do I need, the memory, and so on. And then, of course, all the resources that gets deployed with the Redis Enterprise cluster. Here we have Rec 0, Rec 1, and Rec 2, which maps the real Redis Enterprise nodes that are mapped to pods. So each pod will represent a Redis Enterprise node. And there are 3 because in Redis Enterprise cluster, there is the concept of quorum. So you need at least 3 nodes to have the quorum. And for example, Rec 0, it's the first one that runs, and it's also has the role as a master node. And going back to the Rec, then we also have a bunch of other services like to interact with the Redis cluster itself, health check, and of course the user interface to interact with the Redis Enterprise console. Before going to see the Redis Enterprise console, I'm going to show you the other components with the other custom resources, which is the Redis Enterprise database. I didn't deploy the Redis Enterprise database yet. I'm going to do it in a second. This is basically what you will do in your day 2 operation. So once the infrastructure is ready and the architecture is ready for Redis Enterprise, you may deploy your Redis database, which can come along with your application deployment. You may have a pipeline to build your application, to test your application, then finally deploy to production environments. In that case, you may need to also deploy your Redis Enterprise database. The concept of the Redis Enterprise cluster is to provide a DB as a services within your PaaS platform, within OpenShift. So that's the main concept. It's something that should be delegated to at the application owner. However, let's see first how you can manage the Redis Enterprise cluster. As I show you, we have a bunch of services that you can use. We have the Rec UI. Of course, they will be internal for the cluster. So we're going to create a route out of it. So let's create, really looks like I already did. And let's create a route to access the console. Just implement all the pass-through, and then for any not secure traffic, just do the redirect. So now we can access the Redis Enterprise console. And there we go. It should be. All right. Just let me. Okay. And username and password that you specified during the installation of the cluster. It could have been a secret or just the default credentials or a certificate. Maybe there is also the integration with the a vault system. So it's up to you how you're going to specify those credentials. And here we can see the clusters. We provide a few dashboards also to see what's going on within the clusters, all the nodes that are involved. In this case, 3 nodes which are mapped to the pods in OpenShift. The databases, which can be deployed at console level, but because we like automation, we prefer to use manifest files. So in this case, Redis Enterprise database resources. And I'm just going to show you those files. Let's see if I can bring them here on the console. And this one should be, no, okay, never mind. So let me, hold on a second, just let me stop sharing it and share everything else. And there you go. And all right. So this is, I don't know if it's, let me just zoom in it. So here you're going, this example is a manifest file for creating a Redis database. We are going to provide a secret, and then along with the Redis Enterprise database, which is going to belong to this specific Redis Enterprise cluster, and which is the one that it's already deployed, is going to be the Redis database for the seeker. And then we provide, of course, the Redis database for the player service. This is actually an example to also see that you can specify multiple databases. So to leverage the multi-tenancy capabilities of Redis Enterprise. And if we go, for example, to our console, you can directly, let's see if it's, maybe I think I have a network problem. However, you can deploy directly. Let me see if I can use directly this one. Let's go back to our Redis Enterprise cluster, Redis Enterprise database, and then just go to YAML. And then you can specify here entirely your YAML file. And if you don't know how to write the manifest, of course, we provide this built-in help online where you can really see all the attributes you can specify, plus details, all done for this one. All right. And as you can see, you can provide backup characteristics, and database port, user credentials, memory size, of course, so the amount of memory that is needed, and so and everything will be managed by the Redis Enterprise operator on the entire life cycle of the Redis cluster and the Redis database. Let's see if I can. No, that is okay. Just here, you just need to deploy the Redis. Okay. And here you just need to deploy the manifest for the Redis Enterprise database. Once you deploy the Redis database, the Redis Enterprise database, you can go directly here on the console and then see all the information that that you can have regarding the Redis database, such as the consumption of the resources, and the CPU utilization, the memory utilization, and so on. There is also how you can deploy the Redis Enterprise cluster. The Redis Enterprise cluster goes to one namespace or project in OpenShift, and then the Redis database can be deployed within the same namespace, or eventually you can use the application namespace to provide this logical installation of the Redis database. Why it's logical? Because it will be deployed within the application namespace, but the real consumption of the resources, CPU and memory, will be the one that are of the Redis Enterprise cluster namespace. That's why it's a logical consumption. But splitting like this, you also can gain cost control of your application regarding how much resources are consumed for the Redis Enterprise cluster. And that's about it. Let me stop sharing.
Yeah, and I'll conclude. So.
Oh, we've seen a lot. Just to kind of summarize what we've seen, we've just seen some of the options for managing your Redis. But then as well, what Clément showed in terms of the programming model, I hope you're all impressed, because there's 20 categories, and the ones in red are the ones that Clément managed to show today, which is about half, which is pretty good going.
Well, I didn't show time series because of the time constraint. I was running the time. So, but the codes that you will be able to have are the time series components. So you will be able to see how it's done.
And I think, when you look at that demo where we had such a range of capability and used Redis for every single part of it, you might think, oh, well, we've just fallen victim to golden hammer syndrome, where, when all you have is a hammer, everything looks like a nail. But I don't think that's actually true, because I think the capability in there is so strong that it makes sense to use it. And there's some really good architectural and business reasons as well to keep your tool set streamlined, because all of these tools need to be managed. All of these tools, you either manage it yourself, which is expensive, or you use a managed instance, which again, is going to have a bill for it somewhere. And so having a limited surface area to wrap your head around while still having that full capability is really, I think, quite a neat architecture. And of course, particularly in combination with Quarkus. So Redis is so fast, and then Quarkus is so fast. So together you just get that blinding speed, and then also that great Quarkus developer experience. I think it really does get you to that super database experience. So if you'd like to know more, there's a bunch of resources here that will be available in the slides. We've got a Quarkus guide to Redis. What Clément was showing his application running on was the OpenShift sandbox. So we've got the link for that. If you want to use Redis Cloud, then of course you can go to Redis Labs and do that. And then finally, if you want to deploy your Quarkus on OpenShift, which again Clément showed, then we've got the link for that. And finally, if you would like to see the amazing code for the hide and seek, or if you want these slides, that QR code should take you there. And with that, I think we're done except for the questions.
Yes, we have a question regarding, I'm just going to read it. So, and it's from Fred. Compared to Couchbase cache plus storage, does Redis have something similar to setting durability level? Majority and persist active, the mutation must be replicated to a majority of the data service nodes. And additionally, it must be persisted, that is written and synchronized to disk on the node hosting the active V bucket for the data, valid for Couchbase buckets only. Except for the, of course, valid for Couchbase buckets only. In Redis, we do have what we call an active deployment, which is two different installation of Redis Enterprise cluster, independent clusters, kind of federated together. So they synchronize bidirectionally. So when an application writes to one cluster, the active will propagate those changes to the other cluster. So everything will be synchronized. And of course, if you provided persistency, then everything will be written to disk in the providing with the AOF or RDP. It depends on the use case. So the short answer would be yes. Of course, there are maybe differences between how it's implemented in Couchbase and how it's implemented with Redis. With the Redis Enterprise. Also, in addition to this kind of deployment, we also have the notion of CRDTs, so conflict-free replicated data types. So if two applications write simultaneously on the different clusters, when the data needs to be merged, all the conflict will be resolved in between, so without any conflicts.
Sweet. And I think that's it for the questions, unless there's any last minute questions. coming in, but I don't think so. So I think we can leave it there unless we've got any other last words from Clement and Luigi.
Friday is asking for seeing the last slide again, probably to get the
The
picture
QR
of
code.
the
The QR
barcode.
code. Yeah.
Yeah.
Well spotted.
Well, the slides are probably going to be shared on social networks too. So if you follow, I don't know the Redis handle, but you will be able to find them.
Yeah, we'll make sure that they go out and are findable.
On this, we are already at the top of the hour. We have even 2 minutes behind schedule, so I think it's time to say goodbye. And thank you for having us. And we hope you enjoyed that presentation. You liked what you're seeing, and you are going to try to use Redis with Quarkus on OpenShift with the different capabilities we have shown today.
Cool. Thanks, everybody.
Bye.
Ciao, ciao.